All right, here we go. So, trig, spring. Where's trig spring? There it is. Add a page. Go. All right, so we are finally on 3.3 and 3.4. I'll put them on the same section. It's amazing. We spent all kinds of time on 3.1, 3.2, and then we'll cover 3.3 and 3.4 in one day. But it is what it is. All right. So, note card. So this is sum and difference formulas. So that's the title of this section of your note cards is sum and difference formulas. And they are sine of A plus B equals sine of A cosine of B plus cosine of A sine of B. Sine, cosine, cosine, sine. The letters go in that order, and the sign matches the sign. So then the sine of A minus B is sine of A cosine of B minus cosine of A sine of B. And you go, what does all this mean, Mr. Bierschbach? I'll explain what it means. You just get it down in your note card, and then we'll utilize it. Cosine of A plus B is cosine of A cosine of B minus sine of A sine of B. Oh, sorry. And then cosine of A minus B is cosine of A cosine of B plus sine of A sine of B. Tangent of A plus B is tangent of A plus tangent of B all over 1 minus tangent of A tangent of B. And tangent of A minus B is tangent of A minus tangent of B all over 1 plus tangent of A tangent of B. Okay, those are your 6 formulas that go on your note card. We will still have more on tomorrow that we'll put on our note card. These are today's note card formulas. Okay, so done with note card stuff. Have your note cards out because that won't be up on the board. So, Where is pi over 12 on your unit circle? Get out your unit circles, because you need those today too. Where is pi over 12 on your unit circle? It is a trick question. Very good. Because it's not on your unit circle, is it? Okay. So how do we get to pi over 12? Well, pi over 12 would be like 2 pi over 12 minus 1 pi over 12, right? But pi over 12 isn't on your unit circle, so that won't work. So it would be like 3 pi over 12 minus 2 pi over 12. Now, are those on your unit circle? And the answer is yes, they are. Because what's 3 pi over 12 the same as? Pi over 4. And what's 2 pi over 12 the same as? Pi over 6. Those are both on your unit circle, so this is why we use sum and difference formulas, so we can find places like the sign of pi over 12 and use unit circle to do it. Okay? So, if I want to find the sign of pi over 12, I would take the sign of pi over 4 minus pi over 6. Here's your A, here's your B. And so it's sine of A cosine of B minus cosine of A sine of B, correct? From your note card, it's sine of A cosine of B minus, because there's a minus sign here, so there's a minus sign here, cosine of A sine of B. Well, what's the sine of pi over 4? Square root of 2 over 2. The cosine of pi over 6? Square root of 3 over 2. No, it isn't. Cosine of pi over 4? Square root of 2 over 2. Sine of pi over 6? 1 over 2. So it's the square root of 6 over 4 minus the square root of 2 over 4, which, if you put them over the same denominator, it's the square root of 6 minus the square root of 2 all over 4. How about that? Okay, that's what we're going to end up doing. Now we're going to use some processes to get there, to get better at that. Okay, so what we're going to first do today is we're going to take like pi over 6 plus 3 pi over 4, and we're going to add those together. How do we add those together? Common denominator. Between 4 and 6, what's the common denominator? 12. Okay, so we multiply the first one by 2, so it's 2 pi over 12. Second one by 3, 9 pi over 12. What's 2 pi over 12 plus 9 pi over 12? 11 pi over 12. So we'll work with some adding and some subtracting to get certain numbers. Like we'll take pi over 3 minus pi over 2. Just put it in the maroon basket. What's common denominator for this one? 6. So to get 6, this is 2 pi over 6 minus 3 pi over 6, which is minus negative 1 pi over 6. Okay? So you can see how we can add and subtract to get certain numbers. Okay? All right. So then, how would we get to 13 pi over 12? What would get us to that are going to be on our unit circle? So we can't use anything with a denominator of over 12 with an odd number on top because those aren't on your unit circle. Well, not, I shouldn't say an odd number, but like over 12 that don't reduce. You need something over 12 that reduces that'll add up to 13 pi over 12. So if I would use 6 pi over 12 and 7 pi over 12, could I use those? Because 6 and 7 add up to 13, right? Do both of them reduce? No, 7 pi over 12 doesn't reduce, so I can't use that. I could use 8 and 5, but does 5 reduce? No. I could use 9 and 4. Do both those reduce? Yes. So it would be 9 pi over 12 plus 4 pi over 12, which is 3 pi over 4 plus pi over 3. That makes 13 pi over 12. So this is your reduced form. So we'll be doing some of those of how do we get there, okay? And then you'll be asked to find the cosine of like 15 degrees. Now, when they're in number format instead of radian format, it's so much easier. What two numbers are in your unit circle that make 15 degrees? Adding or subtracting? 45 minus 30 would be the easiest, right? Cosine of 45 minus cosine of 30. And then we'll just do cosine of 45. So then to do this, it's the, whoops, that was wrong. Cosine of 45 minus 30, parentheses. There we go. Wow, Mr. Bierschbach, you screwed up. All right, so cosine of 45 minus 30 is cosine of 45 cosine of 30 plus sine of 45 sine of 30. So what's cosine of 45? Square root of 2 over 2. What's cosine of 30? Square root of 3 over 2. What's cosine of 45? Square root of 2 over 2. Sine of 30? 1/2. Okay? So this is square root of 6 over 4 plus square root of 2 over 4, which is the square root of 6 plus the square root of 2 all over 4. So you're going to have answers with square roots of 2, square roots of 6, and your denominator of 4 anytime you have 12 as a denominator, or you have 15 degrees or 75 degrees or 105 degrees or 165 degrees. Okay? Let's do one more like this. What's the cosine of negative 5 pi over 12? Well, what two numbers get us all the way down to negative 5 pi over 12, subtracting? Negative 3 over 12, negative 2 over 12. Yeah, let's use a positive number and negative number once. So 4 minus what? 4 minus 9. Okay? So then 4 twelfths minus 9 twelfths is negative 5 twelfths, right? So it's pi over 3 minus 3 pi over 4. So it's a cosine of pi over 3, cosine of 3 pi over 4, plus sine of pi over 3, sine of 3 pi over 4 from your note card. That's cosine of A minus B is cosine of A, cosine of B, minus or plus sine of A, sine of B. Okay, cosine of pi over 3, 1/2. Cosine of 3 pi over 4, negative square root of 2 over 2. The negative is important there. Plus Sine of pi over 3. Square root of 3 over 2. Sine of 3 pi over 4. Positive square root of 2 over 2. Positives and negatives are very important. So you get negative square root of 2 over 4 plus square root of 6 over 4, which equals negative square root of 2 plus the square root of 6 all over 4. Ta-da. Think you can handle an assignment over this kind of stuff? Okay, what the assignment is broke up into 3 different parts. The first assignment is. So the first part is adding fractions. So you're adding fractions like pi over 2 plus pi over 6. So you get a common denominator and solve. The second part is finding fractions, or like if you have 105 degrees, what 2 things on your unit circle add up to 105? Well, that'd be 60 plus 45. So you're finding numbers that work. Or if you have 5 pi over 12, what makes 5 pi over 12? Well, it's 3 pi over 12 plus 2 pi over 12, which is pi over 4 plus pi over 6. So you don't have to do anything more than that on your first 2 parts. Then on your third part, you're solving for cosine of a plus b, where you do the whole thing like we did right there. Okay? So there's 3 parts of the assignment. We're doing problems on page 179. We're doing 3, 7, 13, and then 15 through 25 odd. 3, 7, 13, and then and then 15 through 25 the odds. Okay? So that is our first assignment of 2 today.